Welcome to the second video of binomial expansion. Previously, we saw that the binomial expansion formula is given by this formula here. So how did this formula come about? Let's look at the Pascal triangle to find out. So in this case, we are trying to expand 1 plus b to the power of n, whereby n is the power that takes on the value of a whole number. So what it means is, we will first have 1 plus b and the power, let's start with 0. And anything to the power of 0 will give us the value 1. Next, let the power be 1. And so 1 plus b to the power of 1 is simply 1 plus b. And if the power is 2, after expanding, we will have 1 plus 2b plus b squared. If the power is 3, we'll get this term here. If the power is 4, we'll get this term. And if the power is 5, we'll get this term. So let us write the constants and the coefficients in this manner here. So when the power is 0, we simply have only a constant 1. If the power is 1, we have a constant and a coefficient 1. And if the power is 2, we have a constant 1, a coefficient 2, a coefficient 1. So 1, 2, and 1. If the power is 3, we'll have 1, 3, 3, 1. If the power is 4, we'll have 1, 4, 6, 4, 1. Now let's pause here and look at whether we can see a pattern that's going on the right hand side here. You realize that 2 can be derived by having 1 plus 1. 3 can be derived by having 1 plus 2. The 3 here can be derived by having 2 plus 1. The 4 here can be derived using 1 plus 3. The 6 can be derived using 3 plus 3. And the 4 can be derived using 3 plus 1. And yes, we will be able to find the power of 5 using the Pascal triangle here. So we should have a 1 here. So 1 plus 4, the next coefficient will be a 5, followed by the coefficient of 10, which is 4 plus 6. 6 plus 4 will also give us the coefficient 10. 4 plus 1 will give us the coefficient of 5, and we'll end off with a 1. And we can keep going to find other powers as well. So let's compare what we have here on the left. So we will be able to expand 1 plus b to the power of 5 by writing 1 plus 5b plus 10b squared plus 10b cubed plus 5b power 4 plus 1b power 5. And the power will keep increasing. Now, another pattern that we can see from the Pascal triangle is actually we can find the value of 1 using 5 choose 0. We start with 5 because this is for the power 5. And for the number 5 here, we can actually derive it using 5 choose 1. And 10 can be derived using 5 choose 2. The next number, yes, will be 5 choose 3. And for this value here, we can get it by using 5 choose 4. And for the last number will be 5 choose 5. And so another way of writing 5 choose 0 is actually 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. At this point, let us look at how we can use the calculator to find 5 choose 0. So with the calculator, there is a button on the calculator like this. So in order to press 5 choose 0, we will start with the number 5. And we'll press the shift button. And we'll press this button here to activate and choose R. So the value of R is, in this case, 0. So we can find 5 choose 0 by using the calculator, which will give us 1. So for 5 choose 1, we can press 5, shift the button here and then press 1. So 5 choose 1 will give us 5. Let's try one last time. What about 5 choose 2? So we'll have 5, press the shift button, choose 2, and that will give us 10 as well, which is here. So rewriting the expansion in a general way, we can actually write it as 1 plus b power n, 1 plus n choose 1, b, plus n choose 2, b square, plus n choose 3, b cubed, plus n choose 4, b power 4. So if you have n choose r, it will be b power r, and all the way to b power n. Now let us look at 1 plus b power 5 to have a better understanding of this. So just now we had 1 plus 5 choose 1 b, right? Then we have 5 choose 2 b square, okay, from here. Then we have 5 choose 3 b cubed, okay, it will be from here. 5 choose 4 b power 4 all the way to 5 choose 5 b power 5. And if we work out the values here, 5 choose 1, we will have 5. 5 choose 2, we will have 10. 5 choose 3, if you press the calculator, we have 10. 5 choose 4, if you press the calculator, we have 5. 5 choose 5, press the calculator, we have 1. Now compare this with the expansion that we have done manually using the tedious expansion method. Well, you will see that we can actually get the expansion of 1 plus b power 5 using this formula here. Now, if we tweak the formula even slightly and we change the 1 into a's, this will give us the binomial expansion formula. All right, so we will just incorporate the a inside here. And this is how we derive the binomial expansion formula. Now, you do not need to derive the formula, but what we can do is let's learn to apply the formula that's given in the formula sheet and understand the formula slightly better using examples from here. So how do we use the formula? In this case, the value of a is actually 1. The value of b is actually 3a. So since this is the formula that is given, we will have 1 to the power of n. And the value of n is actually 4. So we have 1 power 4. All right? So one way to help yourself is actually to list out the value of a, b, and n on this side here. Next, we will have 4 choose 1. Now the value of a is 1, right? 1 to the power of anything is actually just 1. So we can ignore all this because 1 to the power of anything is just 1. Okay, so we will have 4 choose 1 multiplied by the value of b here plus 4 choose 2 multiplied by b square, and we keep going. Four choose 3 multiplied by b cubed. And yes, you realize that actually the r and the power are the same numbers. That's one way of helping you to keep track. And we must end at 4 choose 4 because there's no other numbers left. And we have b power 4. So let's simplify this using the calculator. We have 1 here. So we have 4 choose 1 multiplied by 3. So it's actually simply 4 times 3, which is 12. Now for this, it may be slightly more complicated. So we can press the calculator. 4 choose 2. 4 choose 2 multiplied by 3 square. That will give us the coefficient 54. Next, we will have one last time. 4 choose 3 multiplied by 3 cubed. And that will give us coefficient 108. And this will simply be 1 multiplied by 3 power 4, which is 81. And we have a power 4. And that's how we expand the term here using the binomial expansion formula. Now, let's try this. What happens if the value, or rather, now let's try this. What happens if the coefficient of the b term here is negative? So how do we address this negative sign or this minus sign here? So once again, we will apply the formula. And a is actually 1. B is actually negative 2b. All right. And n is 5. So let's put these numbers into the formula here. We will have 1 to the power of 5, which is simply 1, plus n choose 1, which is 5 choose 1, and the value of b is negative 2b. Followed by 5 choose 2, negative 2b square. Followed by 5 choose 3, negative 2b cubed. Once again, remember, the value of r and the power here are the same. And 5 choose 4, negative 2b power 4. And we'll end at this last one, which is 5 choose 5, negative 2b power 5. We will have here 1. So we have here 5 times negative 2, which is negative 10b. So we have minus 10b. Then here we will have 5 choose 2 times negative 2 square here. So let's recall, we will have 5 choose 2 multiplied by negative 2 square. That will give us 40. So it's positive 40b square. And if we press 5 choose 3 multiplied by negative 2 cubed. Okay, let's show you one more time. 5 choose 3 multiplied by negative 2 cubed. Please remember to press the brackets. And we will get negative 80. So we will have minus 80 is from here, right? So it will be for b cubed. And the power should be in increasing order in this case. And if we press this, we will have plus 80, b power 4. And if we press this, we will have minus 32. And it will be b power 5. Now, what do you realize about the plus minus sign in between? Yes, it will be alternating. Do you know why? Yes, because of the powers here. When you have an even power, the sign will become a plus. When you have odd powers, the sign will be minus. So whenever you have a minus sign here, your operation here in between will be alternating. Now please try the next two examples on your own. And the answers are given here. See whether you can get this expansion and this expansion. And that's all for our second video.